This question is from GATE Mechanical Engineering of 2019. This is question number 18 of set 1. The question is evaluation of integral 2 to 4 x cube dx using a 2 equal segment trapezoidal rule gives a value of. So we need to do the numerical integration of the given function x cube from 2 to 4 using trapezoidal rule. Before solving this problem using numbers, let's first understand what trapezoidal rule is. The trapezoidal rule is a numerical integral method which can give the approximate value of the function, or we can say the area under the curve. And this is based on Newton's Cotes formula. According to the trapezoidal rule, if one approximates the integrand by an nth order polynomial, then the integral of the function is approximated by integral of the nth order polynomial. Now let's understand the meaning of this statement. Integrating the polynomials is simple and is based on the calculus formula. This means, suppose we have a function y is equal to f of x and we need to find the area under this curve from point A to point B. Now according to the trapezoidal rule, the area under this curve is evaluated by dividing the total area into small, or I can say little trapezoids rather than rectangles. So let's draw the trapezoidals here. Here let f of x, y is equal to f of x, be a continuous function in A to B. Now we are dividing this area in n equal parts, that means n number of trapezoids. So we can say this first green line here, this is x1, the second is x2, and similarly we will divide it till b, which is actually xn. Okay, and this point here, this will be xn minus 1. So we are dividing this area in n equal number of parts. So this can be represented as delta x. So delta x value is x2 minus x1, or from here we can also write delta x will be equal to b minus a divided by n. Now n here is total number of parts or total number of areas, or I can also say total number of trapezoids, right? So this is the first trapezoid from, so we can see here this side, this and this is parallel, so we can say this as y0, the first vertical line, because a is x0, the value of a is actually x0, and x1, this x1 corresponding to this will be y1, and so on. So this will be yn minus 1, the last vertical line will be yn. So we are considering all as a trapezoid, so from here to here. And of course we have the division here as well. I have just not represented it in the diagram. Now it is also established that function f of x is continuous in a to b, closed interval a to b, the function f of x is continuous. Now according to the trapezoidal rule for approximation, if we approximate integral from a to b, this function f of x into dx, this is given by delta x by 2 multiplied by the function f of x0 plus 2 times of f of x1 plus 2 times of f of x2 plus so on plus 2 times of f of xn minus 1 plus f of xn. This xn is nothing but b here, the endpoint. Also delta x, it's already mentioned here, that is delta x, let me write it again, delta x will be b minus a divided by n. Okay, so that means this all small intervals, sub intervals I can say, is delta x. So this is also delta x. Okay, and xi here will be given by a plus I into delta x. Now from here you can observe that as n tends to infinity, the right hand side of the expression, this one, this expression right here, it will approach the definite integral a to b f of x dx. If you want to get the proof of this trapezoidal rule of integration, you can follow the course lecture 10 numerical integration and trapezoidal rule of numerical methods and simulation techniques for scientists and engineers by Professor Saurabh Basu of the Department of Physics, IIT Guwahati. Now let's continue with our problem. Now according to the question, we need to find I is equal to integral 2 to 4 x cube dx. And it's given in the question that we have to assume n is equal to 2. The value of x naught is also given, that is equal to 2. This x naught is also equal to a. Now we need to find this delta x. So delta x is equal to b minus a. So let me write b minus a by n. So b is the upper limit, it is 4 minus 2 divided by n. And we have got, and actually it's already given in the problem, n is equal to 2. So we get the value of delta x is equal to 1. So in the problem it is also mentioned, it's already given that f of x, that is y, is equal to x cube. Now according to the trapezoidal rule, we need to find, to evaluate this integral, we need to find f of x naught, f of x1, x2 and so on, these values here. Okay, so let's try to do that. To do that, we will make a table with x and y. So let's write the value of x in first row and y in second row. So x is given by x naught, or we can write a plus I into delta x. Now here the value of I is equal to 0 because it will start from the beginning. I is equal to 1, I is equal to 2 because we are taking 2 steps. Now the initial value of x will be a, that is given in the problem as 2. The second value I, if we put I is equal to 1 here, and delta x is also equal to 1, so it will be 2 plus 1, that is 3. And for I is equal to 2, the value will be 4. Now let's write the corresponding value of y is equal to f of x, that is also is equal to x cube. Now since this is the value of x, x cube is 8, 3 cube is 27 and 4 cube is 64. So this 8 we can say is f x naught because this is x naught. This value 27 is f of x1 because 3 is x1, and this 64 is f of x2. Now let's use the trapezoidal rule for numerical integration. So as explained above, integral 2 to 4 x cube dx will be given by delta x by 2. So delta x value we have already calculated, 1 divided by 2 into f of x naught. So f of x naught value is 8 plus 2 times of f of x1. F of x1 here is 27 plus the last term, that is f of x2, that is 64. Now if we calculate these values, we will get 63. You can use the calculator for this. And the 63 is the value of integral 2 to 4 x cube dx using trapezoidal rule. Let's go back to the question and write the answer for this. So the integral 2 to 4 x cube dx using 2 equal segment trapezoidal rule gives a value of 63. And this is the final answer that we are getting. Now to get more information on numerical integration such as trapezoidal rule or Simpson's 1/3 rule or 3/8 rule, you can follow the NPTEL course of Numerical Methods and Simulation Techniques for Scientists and Engineers by Professor Saurabh Basu of the Department of Physics, IIT Guwahati. Hopefully I was able to clear your doubt. Have a great day.